Hello and welcome to Skimmer Sediment Basin Design for Construction. This is going to be a short video on basic skimmer design for your typical construction site. My name is Jamie McCutcheon. I'm a 1992 graduate of Clemson University with a bachelor's in civil engineering. I've been practicing engineering for over 30 years and founded CCAD Engineering, which was my own company in 1999. And had it until 2018 when it was acquired by Davis & Floyd. I invented the Marlee Float Skimmer in 2013, and I'm a licensed professional engineer in South Carolina, North Carolina, and Georgia. So we're going to have the Skimmer Sediment Basin Design webinar objectives. Pretty simple, just understand the basic skimmer basin design based on volume for sediment basins. We're going to have some future topics we'll go over that'll include advanced sediment basin design with SEDCAD, skimmers for permanent use. We'll do a case study. We'll talk about advanced skimmer modeling and hydroflow. We'll talk about volume-based versus filtration-based water quality. This is really a new idea in providing water quality in detention basins, and one we're very excited about. Then we'll talk about water quality modeling and how to do that volume-based water quality versus filtration-based design. So sediment basins with skimmer withdrawals from the surface or near the surface, allowing sediment to settle to the bottom. This is an EPA requirement in most states, and the Marlee Float's a little bit different in that it takes water from just below the surface rather than directly on the surface, and has a debris guard to keep trash and debris that's floating on the surface from reaching the orifice. There are a number of different skimmers on the market. The Faircloth skimmer is one of the popular ones, along with erosion supply skimmer or ESC, the Marlee Float, and the IES. So one of the big things about skimmers that is a misnomer or misconception is that skimmers are constant head, constant flow devices. And while they are relatively constant head, testing has shown they're not constant flow. This is an example of testing that was done by TRI Environmental for Georgia, and they tested 3 different 3-inch skimmers. You see here at the top right, a type 2, type 1, and type 3 3-inch skimmer. Their test tank is 4 feet deep, so 0 to 4 feet. And you'll see that 2 of the skimmers had similar flow rates at 1 foot of depth, around 37 GPM, while the other 3-inch skimmer had a 70 GPM flow rate, nearly double. And all 3 versions had about a 25% increase in flow rate from 0 to 4 feet, again with 2 of them being similar, around 50 GPM, and the other being nearly double again at 90 GPM. And so the point here is simply it is critical to compare flow rates and not just skimmer size, or you may not get the flow that you're looking for. You'll also notice that state sediment basin standards differ across state to state. Here's a chart of a few states that we cover, and you'll see South Carolina, for example, the basin volume is 3,600 cubic feet per acre. North Carolina is half of that at 1,800 cubic feet per disturbed acre, not total acreage. Georgia is 1,800 cubic feet per acre, and Ohio is 1,800 cubic feet per acre, plus an additional 1,000 cubic feet per acre of disturbed area for sediment storage that is located below the invert of the skimmer. So basically a wet pool. And then Kentucky's on here, but pretty much everything in Kentucky has to be calculated. So a soil type dependent, and then most other items have to be calculated. Surface area, there's 2 different equations. North and South Carolina use a similar equation of 325 square feet per CFS for the 10-year 24-hour storm. Georgia uses an equation that's based on the 2-year storm. If you run those, the numbers come out fairly similar. Ohio doesn't specify a surface area, just has a max depth of 5 feet, so you don't have a deep, narrow basin. And again, Kentucky has to calculate it. Principal spillway would be considered the skimmer and typically the riser structure. So design basis for that is anywhere from 10-year to 2-year storm. Emergency spillway, again, that's the overflow for a larger storm event, and that's anywhere from the 10-year, 25, or even the 100-year storm in South Carolina. Interesting where skimmers are required. South Carolina is 10 plus acres, but they're preferred for smaller. North Carolina, we've seen sites smaller than 1 acre require skimmers. Georgia, they're preferred. Some MS4s do require them. And then Ohio is 10 plus acres, and Kentucky is 5 plus acres. Then the last item that you need to factor in is dewatering time. And so in South Carolina and North Carolina is 2 to 5 days. Ohio is 2 to 7 days. Georgia leaves it up to the engineer. They don't set a standard. And then Kentucky requires you to calculate it to make sure you receive 80% trapping. Note that some MS4s may have differing requirements on these general requirements. Also, we see some DOTs have different requirements than state standards from time to time. One thing that states are starting to incorporate and recognize is that skimmers do have different flow based on their specific designs. And so orifice size and associated flow rates are product specific and should be based off product specific testing. We know Georgia and South Carolina have this in their manual. We're starting to see more states add this as in their manual as well, recognizing that, like we showed on the chart before, not all skimmers flow the same. So to design a sediment basin, we created a very simple design tool. It's an Excel tool that can be downloaded from our website. We have a block here for your project information, so your date, project name, location, company, engineer, your basin description. You may have more than one basin, so maybe basin 1, 2, 3, or ABC, however you identify them. Give you 2 other spaces for just other information if you need it. We have a check here to confirm your required dewatering volume. This is a common issue that we've heard from reviewers and regulatory community, that sometimes engineers don't base the skimmer size on the required dewatering volume, but rather the total volume of the pond. So this is a simple check. Put in your total acreage and your volume required. So in this case, whether it's 3,600 cubic feet or 1,800 cubic feet, and you'll calculate that volume. Then the other place you do your inputs is here in this block where the inputs are. So here we set a range of time to drain. So in this case, we've got 48 to 120 hours or 2 to 5 days. Your pond depth, pond top length and width, and bottom length and width. Now it's important on pond depth to identify the depth that it takes to meet your required volume. If your basin's 10 feet deep, but you meet your required volume at 4 feet or 3.2 feet or whatever that may be, set your pond depth to that depth. Your top length and width and your bottom length and width, we recognize there's very few basins that are rectangular or square, so simply use your engineering judgment to adjust these numbers to what makes sense, and it will calculate the volume for you. And what you want to do is try to shoot for a calculated volume roughly within 5% of your required watering volume. Again, typically you're looking at a 2 to 5 day range, or say 2 or 3 day time frame, and so it's not necessary to get this calculated volume to exactly the required dewatering volume. Once you have that, you'll go down to the bottom of the page and there's a skimmer report tab. When you click on that tab, it'll take you to a nice neat 8.5 by 11 for your report or to put on your plans. The top portion of this report is going to show you that your calculated pond volume is similar to your required pond volume. It's going to have all of your inputs that you put in, and then it's going to have your maximum time to drain, which will be your minimum flow rate, and your minimum time to drain, which would create your maximum flow rate. And then because it is our tool, we're going to give you the drawdown time for every one of our skimmers in each orifice configuration, and then based on your established time frame, which skimmers meet that and would be acceptable for this project, then you as engineer will select which skimmer you prefer and specify that on your plans. Often we just see engineer just highlight whichever one they prefer. We typically recommend trying to shoot for somewhere around the 3-day time frame. So in this case, I probably would go with the 4-inch skimmer with a 3.5-inch orifice at 68 hours. Would be a typical, but again, it's up to the engineer and what your local requirements are. We also have details available on our website, and so we have 4 separate details currently. They are for a temporary skimmer basin with it that is a dry, or we have a temporary basin with a wet pool. But so in this case, it just typically be a barrel pipe with your skimmer attached to it and an emergency spillway. We also have a wet basin, so you have a permanent pool here with a riser structure. We have this version for dry and wet basins as well. You'll notice we have a skimmer sediment basin design criteria here. Has some general information. Again, specify if you've got sediment storage required, dewatering volume required, surface area requirements. Key point here is your dewatering time. Establish your minimum and maximum on your plan set. And then in this case, if it's a wet basin, you've got sediment storage and dewatering volume shown here. Again, you want to base your skimmer based off your required dewatering volume because your provided could be quite large compared to that. If this is going to be a multi-purpose basin and become your permanent detention pond, it's not uncommon for your detention pond to have 3, 5, even 10 times the volume in the total basin versus the required dewatering volume. And then you've got your data information here. So whichever basin number, drainage area, disturbed area, flow, surface area, etc., bottom of basin, outlet, barrel pipe, top of riser, merge spillway, spillway width. And here's the important stuff. So you've got your skimmer size, you've got your skimmer orifice diameter, your skimmer type. Again, skimmers of different types flow differently. So obviously it's our products. We filled in the Marlee for you, but you can change that if needed. Is an equal allowed, yes or no? Now, we recognize most of the time that's going to be yes, but there may be some times where it's no for a reason. And then the other key thing here is to specify your skimmer flow rate, your minimum and maximum. So when you do that and you go through the review process and the reviewer approves your range of time and your range of rate, if your contractor decides, hey, I would like to change from whatever is specified to a different skimmer, is that allowed or not? All you have to do is check the flow rate for that specific skimmer, make sure it falls within your range, and you're good to go. You don't have to do a full redesign. Then also we have our details, again, available on our website to download. All of our details are available in CAD and PDF, so they're easy to edit. They're not locked in CAD. A couple of things to point out on the detail. All of our skimmers come with an orifice plate that goes in the skimmer, so it's very easy to change the orifice size. All the skimmers, I know you can't read this top block, but they come with the flow rate for each skimmer and orifice configuration in the skimmer from 0 to 4 feet deep. Our coupling is a little bit different. It's a bellows type coupling, so it's relatively stiff to hold the skimmer in place. And then we always recommend that the pipe between the coupling and the skimmer be 1.4 to 1.5 times the height of the riser structure. Typically, we want about a minimum of 8 feet. So if your riser structure is only 3 or 4 feet tall, we'd recommend putting a minimum 8 foot of pipe in there anyway. But you need a minimum of 1.4 to 1.5, so as the skimmer comes up, the flexible coupling only has to flex about 45 degrees for it to rise. And again, it's still a little unclear, but that's the flow rate for this particular skimmer with each orifice configuration. Then lastly, just a couple of things to wrap up. This is a pretty good skimmer install on a dry basin. See the baffles are in, they've tracked the sides, got their stone pad, skimmer's been put in place. One thing I'd like to point out here is the stone pad you see is sitting on top of the soil as it's been graded, and there's not a depression here. So when it does rain, you're going to have 6 to 8 inches of water sitting in this basin that can't get out. It has to infiltrate in or evaporate depending on the soil conditions, or just stay wet. Going to be hard to get grass established in that condition. So we always recommend to provide a depression so that skimmer sits down and try to drain the basin fully. There have been some really bad installs. This is one of our favorite pictures, or I guess least favorite installs. Everything's done wrong here. There's no flexible coupling. The pipe is about a foot. It looks like it should be at least 10 or 12 feet. And if you look close, they left this valve open on the side so that all the water's bypassing the skimmer anyway and just going straight out. So unfortunately, there's sometimes things are not done well in the field and do need to be corrected. We have seen a couple of skimmers installed, or at least 1 or 2 installed upside down. Again, the coupling here is put in, but the pipe is too short, so the skimmer's not going to float up much anyway. So it's really going to probably drain this basin down okay because the skimmer can't float. But if the pipe was in there right, you'd have a hard time getting it to drain if the skimmer's upside down. And the last thing here is skimmers are not maintenance free. They do require some maintenance and routine, just checking them, make sure they're not clogged. This particular skimmer had actually vegetation growing out of it, so if you see vegetation coming up out of the skimmer itself, there's probably a problem. This one had a large root ball in it and needed to be cleaned out. So thank you for watching. This is just a quick skimmer sediment basin design basics. Hope that you can use this in your work and getting your permits. We can provide continuing education credit, just a little 15-minute credit for this one. Just email us at info@rymarwaterworks.com if you'd like to receive that. We'll send you a little short quiz, and make sure you watch the video, and then be glad to send you your credit. Keep an eye out for our other series that's coming soon on the other topics we mentioned at the beginning of this, and thank you for watching.